स्टोरेज फुल हो गया।
स्टोरेज तो नहीं फुल होगी मेरा
मेरे ख्याल से हो गया होगा। 12 GB की वीडियो बनी।
फिर स्टार्ट दोबारा हो तो निपटा
नो स्टोरेज।
This is for one point. Yes.
Shear and negative shear both will appear at the same time, so they will cancel each other.
No. What we are trying to do is find out the maximum shear positive, the maximum shear which is negative, maximum positive moment and maximum negative moment. That's what we are trying to find out.
Then they will appear. Yes.
They are not going to appear at the same time. They will appear at different time. But for the beam, we need to know when it would have the positive shear, when it would have the negative shear, and all that. Okay? So, therefore, it is important that we find out all these values. Okay? And from there, we will draw our envelope. We will further shrink it, draw our envelope, and then we would have the final value. Okay? So I'll see how, I'll let you know how it works. So live load is okay?
Yes, sir.
Now there is one another live load which is the concentrated one. So there is 25 kV. Live load which is 25 kV. Now what should I do? What should I do in the case of 25 kV?
सर ई पॉइंट पे अप्लाई करते हैं, we will have a maximum shear effect.
Where should I apply? So V max
at E point.
V plus max is equal to 25 into this is 0.4, this is 0.3. So obviously 25 into 0.4. For the negative one, we will multiply 25 with 0.7. What is this? V plus max 25.4.
10.
This one this one and plus yes. Sorry? This 25. Why have I not multiplied? Why?
We need maximum.
Because 0.3 is less than 0.4. No, but this is going to be applied at one point at a time, isn't it?
Concern is
25 kip is running like this. Okay? 25 kip is running like this. So that will be applied at one point.
Sir, why that point is 0.4 and not 0.3?
Sorry? No, because I am saying that 25 kip is running along this. Okay? So you apply it. So it is going to be either at 0.4 or either at 0.3. It can't be at both the location at the same time.
Yes, sir.
In the case of live load, which is these loads, they can be at different locations. Why? Because these sort of loads, okay, this is like, for example, weight of people which are in a room. Okay, so there can be some people on this side, some people on this side, some people on that side. Okay, this is normally when this say 25 kip, so this is like a one concentrated load which is moving straight along the beam. So this might be weight of some car which is moving. Okay, so this is different. Okay, or this might be a forklifter lifting some weight and then moving along. Okay, so that's why it is only at one location. That live load is at different location. It can be everywhere. You can spread it around.
रेड लोड यूनिफॉर्म कंसंट्रेटेड बनना असाइनमेंट दे दे पहले डीपी चेंज के मिनट बाद
Okay? Shall I wrap it off? Now we draw our imbalance. So V plus max. What is V plus max? This is negative. So V plus max is 6.24. Help me out. 6.24
इससे ज़्यादा 25 की 10 की
plus
10K.
10K. V minus max is
Minus 7.84.
minus 1.2 minus 7.84 minus 17.5. So how much? M plus max plus 28.8 plus 67.2 plus 105. Minus 28.3. Okay, so this is our envelope. This is the maximum positive shear, maximum negative shear, maximum moment, and maximum negative. So this is our envelope with respect to section 1.1. But what did I, okay, so this is for only one section. Yes? In bridge engineering, what we do, what did I tell you? That we have to find it out for every 10th location. Okay? So if it's a 60 feet long, if it's a 60 feet long bridge, so we, at every 6 feet, we do the same exercise. At every 6 feet. Obviously, we can't do it by hand, so we use computers to do that for us, or spreadsheets, okay, Excel sheets. But we do it for each and every point, at 10th point along the length, okay? And so we get, and from there we find out our maximums and our minimums. And yes, obviously, then you have to multiply with the factors and all that. Yes, this is for the maximum combined effect for all three of them. Yes, because normally you will see now in your next semester when you are doing design subjects that your dead load and live load they are added together. Okay, so this will give you the maximum. Is it okay?
Yes, sir.
Okay, now okay. For example, if we have a fixed speed, yes, and it's a point in the middle. So what did we say? What is the influence line diagram for shear?
For the shear, it will be spread. More shear.
Would it be like this?
Yes, positive shear.
So there is only positive shear, isn't it?
Yes.
At this location. So whenever your load is over here, you will have some shear developing. And then there is no shear. Okay? Is that okay?
Yes, sir.
So now in this case, what will be your V positive and V negative? V positive is this one. This will be just 1. What is V negative? 0. Okay? V negative will be 0. So if I give you something like this, please remember V negative will be 0.
Yes, sir.
Just follow your influence line diagram. Okay?
Influence line diagram is always linear.
No, it is always linear for determinate structure. For determinate structure, it's linear. For indeterminate, it's not.
Sir, can you calculate shear forces and bending moments for the UVL?
For the
UVL.
for the UVL. No, for UVL normally we don't have a UVL running along the beam. Okay, we don't have UVLs, and either it would be UDL or either it would be some set of concentrated loads. Like I'll show you what do I mean.
Saksha Miraj. Moment of silence.
Okay. Okay, so what we have is in bridge engineering, and we know that in case the influence lines are mainly influence line mainly find their application in bridge engineering. Okay, in bridge engineering we have a bridge which is subject to many live loads in the form of vehicles. Normally, the vehicles which are like ordinary cars, okay, it might be small cars, medium level cars, they are not of that concern. The main vehicles which are of concern and which are actually used as a design load, they are big lorries, okay, heavy lorries, like you know the big concrete mixers. Yeah, heavy lorries which have, you might have seen, they are carrying lots of cars, okay, and they are actually very heavily loaded structures. So, this I have taken from AASHTO. Have you heard of AASHTO? Yes, this is from AASHTO live load calculations, okay, and in AASHTO, this is a standard lorry which has got these axles. You know that axle has got two wheels. Okay, so you have got, so if this is 8 kip in the front axle, per wheel it will be 4 kip. Yes, and then the wheels which are behind, they are the rear axles, and each one is considered as 32 kip. This is a very heavily loaded truck, and the front, between the front axle and the rear axle is 14 feet distance, and in between the two rear axles there is 14, the distance is 14 to 30 feet. Okay, then after that you can have a tandem attached behind it. Okay, so with a hook or something you attach another two-wheeler, two axles, and you can place more stuff on it. Okay, so that is called a tandem, which is attached behind it, a lorry which is attached behind your main vehicle, and that has got normally, that's considered 25 kip 25. Now this is for the concentrated load. Beside this, we have 640 pound per feet. That is the live load UDL. We were doing 2 kip per foot. Yeah, the code says that you apply 640 pound per foot, 0.6 kip per foot. Okay, so that is applied. So if you apply the same thing on this beam, on this bridge, okay, on this bridge you apply the same load. So this one is easy, 0.64, you use the same procedure and find out your maximum. Okay, how would you apply your lorry load? Yes, so you have to place the whole lorry at the same time at certain location. So if I ask you, I want to find the maximum shear, okay, maximum positive shear. So where will you put your lorry?
Maximum is 0 to 15 meters.
Where should you put your lorry? The first question is that how much is the distance between these two wheels? So I ask you first of all, which one will be more intensive, 14 feet or 30 feet? Why 14? Because yes, because if you lump all the loads together, then that's the worst case. Rather than you spread it out.
Yes, sir.
So obviously you will take the 14 feet one. Is that okay? You will take the 14 feet one, and you will. So this is 14 and this is 14. Now that's established. Now you will place it somewhere over here.
Yes, sir.
So where should you put it?
0 to 50.
Sir, from A to
Maximum area.
So for maximum positive, either we put it over here or we put it over there.
Yes, sir.
So we can find it for both of them. Point 4, so your lorry will come, 8 ship will be here. So 8 kip will be here, and then you will have,
32.
and you multiply that with the corresponding
Area.
not area. This is not area, concentrated load. So with the corresponding ordinate. And similarly, you will place it over here, and you will multiply it with the corresponding ordinates.
Yes, sir.
सर हमारा जो ट्रक है उसकी अपनी रेंज है 14 प्लस 14.
Yes, that I know. So imagine this is 12 feet, this is 18 feet, whatever. I'm just giving you an example. Imagine these are very long lengths. Okay? Imagine these are very long lengths. Do you understand my point? How do you do that? You take this one, you take this lorry, and now in order to find out maximum, you have to place it somewhere. Okay? So this is my positive and this is your positive. So your lorry can be over here.
What does Oslo stand for?
Okay? Your lorry can be over here. 8 kip and so on and so forth. Or your lorry can be 8 kip or other way around. 32 kip over here, 32 kip over there. Is that okay? So either on this side or on this side. And similarly, you're on this side. That is for negative. In the case of, sorry, that's for positive. In the case of negative, you have just this one area, so you will put it over here. 8 kip, 32, 32. And you can find out your maximum. You understand my point? And similarly, you place this lorry. In the case of moments, you have to do the same thing. Okay, place it over here, and then on this side, on this side, on this side, and on that side. G.
American Association Society of Hydrogen.
Sorry, say it again.
First case where we put the lorry at 0.4,
American Association
In the first case, why do we? Sorry, say it again. I couldn't catch you.
in the first case, where we put the lorry at 0.4,
Excuse me, can I listen to him, please? Yes.
where we put the lorry at the 0.4 position,
Why don't we place the lorry at 0.4 kip? Yes, so that's what I'm saying. You can do it for all of them. You have to do it for all of them.
that's what I'm asking. Why not just for 0.4 because it is larger than 0.2?
Yes, so, but I mean, I don't know whether at 32 kip this is bigger or not. 32, I haven't done the calculation.
Yes, sir.
Okay, similarly, this one magnitude is larger, but I don't know whether this one and this one will give me the larger value. Maybe this one might be dominating, or that one might be dominating. So I have to do the calculation. Yes, I mean, like, you know, if you are surely, if they have got the same slope and this has got the same area, and you can rule it out, so you rule it out. But the main point is you have to check all of them. Any question about this one?
Sir, what about the design lane? What is this?
The design lane is the UDL. This is the live load, which you can apply anywhere. The concentrated load which I did 25 kip, that was just one axle. Okay, now, but in reality you have 2 axles. Okay, or 3 axles, something like that. So, now, so we have got this lorry. Now this lorry you can place anywhere and you can find out your maximum positive, maximum negative. Do you understand my point?
Sir, we,
That load the weight of the beam itself.
Yeah, dead load is the weight of the bridge and all the topping on it, whatever you have, the pavement load and all of that. So that is the dead load. Okay. Yes. Any question? Ask me. Is that okay? Okay. So that's it. Okay. Can you please switch off? Okay. Yes. That's
experts.
for first principle.